HVAC 360, episode number 68, Thermostat Operation and Thermal Comfort. Hey, welcome back, everybody, to another episode of HVAC 360. I'm your host, Matt Nelson. HVAC 360 is a podcast that covers everything concerning HVAC, from the people to the topics, talking about engineering, commissioning, construction, building operation, what have you. Those are the topics that we like to cover. Sometimes we get real technical. Sometimes we get really basic. And that's, in fact, what we're going to be doing today. We're going to get real basic for a couple specific things. Two topics in particular, interrelated topics. We have thermostat operation and we have thermal comfort. Now, before I get into those topics, I'd like to thank our sponsor. Really appreciate the Building Commissioning Association getting behind HVAC 360 and supporting the cause here. We're all in favor of education, trying to make sure that the built environment is a better place every day. If you're involved in the building commissioning aspect, and obviously that's the angle that I'm coming from. That's my day job. Is the Building Commissioning Association is really the place to be. They have a lot of great webinars that go on in the fall and the spring. Looking forward to those. Obviously, in the spring, they also have the National Conference on Building Commissioning. That's something that you can always looking forward to. I mean, if you think about a one-stop shop for your commissioning education and your networking, that's definitely the place to go. Go and meet people, go and network, go and see the different vendors that they have there. Really a great opportunity. So where can you find all this information? Just go to the website. It's bcxa.org. That's bcxa.org, and that will have all the information. If you're so inclined, sign up and become a member. If you were looking for certifications, obviously as a CCP, that's personally one of the certifications that I haven't gotten yet, and that I look forward to getting in the near future. So that's one of the things that I've had plenty of certifications, but that's just one that I want to kind of wrap up my certifications with as far as commissioning goes. I really want that one. So that's one that I have yet to take. And so, again, thanks to the BCA, the Building Commissioning Association, for sponsoring HVAC 360. So let's talk about thermostat operation. Now, I know most of you have a pretty good working knowledge of how a thermostat works. But I wanted to be able to say, hey, there are times when you're trying to explain this to an owner, or whether you're trying to explain it to a users group, or even, sometimes even maintenance staff don't really fully understand how a thermostat and how that operation works. So I wanted to come up with some sort of, visual analogy of how a thermostat works. And I come up with the analogy of a tug of war. So in a tug of war, you have two teams that are fighting, are pulling against each other to get a flag that's kind of in the middle of the rope. So the way I kind of set it up was like this. You have one team would be a robot, and that would represent your HVAC equipment, and it would do as you kind of command it. The set point is going to be a red flag in the middle of this long white rope, and on either side of that, you're going to have two black markings, and that's going to represent kind of the dead band of the operation. And the opposing team to your robot is going to be some sort of elemental creatures. So you got like fire creatures or ice creatures, depending on what kind of outside air conditions that you have. So in the beginning, before you start the competition, you have the robot, and you kind of say, okay, you know what? Your job is to pull the rope until you get to the red flag, the set point. And you keep pulling until you get to the red flag, and then when you get to the red flag, you can stop. But if you ever cross the black marking again, if the rope slides out of your hands and it crosses the black marking, then you are to activate again, and you are to start pulling towards that red flag again, that set point. So your fire and ice creatures, they're just going to be, out there to kind of wreak havoc and try to win the competition. So in your cooling scenario, you have your robot and it has its orders. So it pulls and pulls and pulls and pulls and pulls, and eventually it'll reach that red flag, that set point, and then it'll go into its sleep mode. And while it's in its sleep mode, you're going to have the red fire creatures. We're talking about cooling conditions. So you have summer operating temperatures, and you have the fire outside, so it's really hot outside. So your fire creatures are pulling the rope back, and all of a sudden you cross that black marking, which is your deadband set point, and the robot wakes up, and then it starts pulling towards the red flag and the set point. And you kind of have this back and forth kind of thing that keeps going on and on. Now, this is kind of not just a kind of a once in a while kind of deal. This is kind of constant, every day. And there's a couple of different things that you kind of modify into it, or kind of get the understanding of it. If you have a condition where it's your design day, and you've kind of bought your robot and you've constructed your robot to operate during that design day, that design competition, it's going to work and it's going to reach that set point, and it's continually go between the deadband and the set point, going back and forth. And it'll do a great job. And it'll be doing it at an appropriate speed. But some cases, it's, since this is an everyday kind of competition, some cases you're not going to have that many fire creatures on the one end. It's not going to be that hot. And you're going to reach that set point more quickly. And then you're going to go back to the deadband. And then you're going to activate it. You activate your robot, and it's going to go back to that red flag and that set point. And there's going to be other cases where it's going to be above design conditions, and your robot may struggle to actually reach that red flag. It may never even do it. And in fact, in the worst case scenarios, and you really don't like to tell the owner this, is that you're never going to reach that red flag. You're never going to reach your set point, and it's going to kind of continually drift away until the sun goes down and all the fire creatures go back to sleep. To which your kind of natural reaction is, well, you know what? I'm going to build this giant robot to do all my cooling for me, and we'll reach that set point. Well, that doesn't do you any good anyway, because not only is that going to be an expensive robot, but that robot is going to have to, as soon as it wakes up, it's going to reach that flag real quick, and then it's going to go to sleep. And it's going to wake up and go to sleep. And that's like the cycling of your equipment. And that just, that wreaks havoc on your cooling system as well, kind of, reaching that cooling set point too quickly. Not only is that going to be cycling, but, the real world effect is that you don't have that constant dehumidification that you really want. So it's going to be cold and clammy as the kind of conditions that you get when your system is oversized. And that's really what you don't want. You want a appropriately sized robot. So you get the other condition. Sometimes you're pulling all day and you're reaching that set point, and then the fire creatures go, okay, you know what? I'm it's 5:00, time to go home. But what you don't realize is that there's going to be ice creatures on the other side, kind of pulling that set point, right past you, and then it goes into a cool or a heating mode because it's getting too cold, and you need to heat up the building. And when it reaches that other set point, that other deadband set point, it's going to want to heat. But in some scenarios, it's going to be like, well, you know what? I've been programmed not to heat, during the summertime, or I don't have any heat to give, and the set point is going to continually drift away in the other direction, and it's going to get colder and colder. And that's the scenario you have in some cases where you have equipment and there's no heating coil, and you end up subcooling the space, and there's nothing you can do but subcool the space. So, but in a lot of cases, you have that reheat coil, or that reheat capability, and then your robot can, I'm going into heating mode, and he turns around and he starts, pulling towards the set point in the other direction, and then you get that the back and forth between the set point, that red flag, and the black markings for the deadband going back and forth. So that's kind of my analogy that I've kind of put together. Hopefully that wasn't too convoluted of a analogy, but I just thought it would be kind of that kind of description where you're pulling you're pulling towards a common set point, and kind of letting it drift for a little bit, and then hitting that dead band and start pulling again. Taking a rest there periodically, and the fact that you have different sizes. Different sizes of equipment for the robots. You have different sizes of your competition for your, fire creatures or ice creatures. And sometimes, that's the reality that sometimes you're not going to be able to satisfy people 100% of the time. But ultimately, when you're a design engineer in your HVAC, thermal comfort is really what you want to be, focusing on. And really you achieve that through the operation of the thermostat. So, thermal comfort. Let's talk a little bit about thermal comfort. That's the second half of this two-part conundrum. Thermal comfort, we talk about typically when you mention thermal comfort in ASHRAE circles, you're going to end up with ASHRAE Standard 55, which is thermal comfort standard. But I didn't have it on hand, so I went to my handy-dandy ASHRAE books and checked out the fundamentals. This one, particularly Fundamentals 2009 edition, Chapter 9 on thermal comfort. And, I kind of, let me read you a little bit about, from the chapter about human regulation. And it says here that, skin temperature greater than 113 degrees or less than 64.5 degrees, and this is degrees Fahrenheit, causes pain. Which is, I'm just pulling this out of, the text here, but it's interesting, 64.5 degrees. You realize that most cooling actually gets discharged out of the HVAC at 55 degrees. So realize that when you have situations where you have air blowing directly on people, it's very uncomfortable. I get that scenario all the time when I'm in a car and I have the air conditioning on. I mean, sometimes I'm really hot and the air conditioning feels good, but if it blows, if I get comfortable and then it still continues to blow on me, it's going to be very very uncomfortable, and it makes me achy when that happens. So realistically, from the studies, 64.5 degrees Fahrenheit is kind of the lower end of the threshold of pain. Basically, skin temperatures associated with comfort at sedentary activities are between 91.5 degrees and 93.5 degrees. That will decrease and increase with activity. Another little tidbit of information here. Thermal temperature regulation center in the brain is about 98.2 degrees. And I thought that was the interesting part was that it turns up it cranks up to 99.3 degrees Fahrenheit when you're walking, and 102 or 100.2 degrees Fahrenheit when you are jogging, which is kind of one thing that I never really thought about before is that you talk about like the runner's high and things like that. If you actually get a different perspective, or your brain starts thinking in different ways when it heats up with activity. Obviously if you're sitting at a desk, it has a single temperature, but when you start walking or when you start jogging, the temperature of your brain goes up, so it may react differently. I was thinking about, and this is kind of way off topic, but you think about a fever, and you have a higher fever, and you start to hallucinate. But if your brain starts operating at a higher temperature, it's just one of those things that made me think. From reading the fundamentals, which is very, very technical, I just had to put that into perspective a little bit. So the one thing about Chapter 9, and the one thing that I wanted to focus on, is that you know from ASHRAE 55 that you're never going to satisfy everybody. You get your 80% is really what you kind of want to shoot for before you have to actually take some sort of remedial action in any sort of the satisfaction surveys. And really, the one thing that you've seen, and I'll put this in the show notes, is the chart basically the ASHRAE summer and winter comfort zones. It's actually figure 5 here, but I will put a link to the show notes. And if you have never seen this, it's kind of interesting. You get the at the operating temperature on the x-axis, and that's the degrees Fahrenheit, and then you have the relative humidity lines, and you'll have these comfort zones depending on your clothes. Now, ASHRAE has, of course, or not ASHRAE per se, but the people researching the comfort, the thermal comfort, they came up with a kind of a variable called a CLO, and that's CLO. A CLO actually describes how much clothing that you have on, and obviously in different parts of the Fundamentals Handbook, you have your different CLO ratings, and if I would say if you had a CLO of 0.5, one example that they have, let's say, if you had trousers and a short sleeve shirt, that would be a CLO rating of 0.57. However, if you were to have trousers, a long sleeve shirt, a long sleeve sweater, and a T-shirt, there would be a CLO rating of 1.01. Now, I think the one thing to kind of deduce from this is that obviously, if the higher the CLO rating, the more clothes that you have on, and in general, when you're taking a look at, say, a office scenario, you know that men and women dress differently. They definitely have a different CLO rating range. I mean, typically in an office, if you have a tie, some sort of dress code that has a tie and a long sleeve shirt and pants, that's going to have a different CLO rating than women that may wear a blouse or a thin dress or some sort of a skirt. So that definitely plays into the fact of the different comfort ranges of the different people that are going to be working in an office environment or wherever environment they have. So that is one thing about thermal comfort that is interesting. And hopefully that kind of explains a little bit maybe about what a CLO is and the ASHRAE 55 and where you can find it in the ASHRAE Fundamentals. So, all right, well, I think that's pretty much it. I just wanted to get something out. I've been kind of busy as of late going to different projects and working out of town, and actually had a vacation. And actually, you know what? Now that I think about it, this is one of the other things I was going to say. Thermal regulation, because I went camping. And one of the things about thermal regulation is that the campfire is a really great kind of another analogy of thermal comfort and kind of the adjustments. Because obviously you have a heat source in the middle of a ring of people, in this case. And depending on what you're wearing, it might be, the fire might be too hot, too cold, so you end up kind of modifying your distance from the fire by backing up or moving forward, or maybe putting on a sweatshirt or something like that, so you can kind of regulate your own temperatures. But it's again, you can either change the distance from the heat source, or you can adjust your CLO rating to kind of get you in that thermal comfort zone. Now, I know that a lot of people, when you talk about sustainability, I've heard it said that you can actually, if you have fresh air, if you smell fresh air, you can actually have a higher tolerance for a higher temperature and slightly higher humidity if you have that fresh air sense, which I thought was, it's very interesting. A lot of this, is a little bit psychological when you think about it. And I think that's, fascinating aspects of the thermal comfort topic. So, again, I hope this helps a little bit, at least a different way of looking at things, whether it be thermostat operation or thermal comfort. I appreciate each and every one of you listening. And if you like the episode, pass it on. I appreciate it. That's probably the best way that you can do. If you like the episode, or if you like what you're hearing here, you can also let me know via iTunes. I appreciate those. Any sort of ratings that you can give or comments, that always helps. Helps the podcast become more popular and gets it a higher attention in the iTunes Music Store. I appreciate that. Also, if you have any sort of comments, if you thought this was kind of off your rocker, or you would appreciate some other direction, please let me know. You can always reach me at matt@buildingx.co, or if you have other show suggestions, comments, opinions, you can find me there. Check it out at check out the blog at buildingx.co. If you want to follow me at Twitter, it's at buildingx, and on LinkedIn, I always like to kind of connect with those people who are listening to the podcast, and I'm at Matt Nelson PE on LinkedIn. So that's all for this week. I appreciate each and every one of you. Thanks to the Building Commissioning Association, again, for sponsoring this podcast. And as always, remember, know what you build and share what you know.